Good morning to all. Today we are going to study about an construction material. The topic is stone. So basically this unit consists of introduction about the stones, their characteristics, properties, querying, its deterioration, retardation, preservation. So first in today we are going to study about the characteristics and their testing and uses. So we all know about the stones. The stones are generally used in construction. They are hard, durable. They are resist to wear any kind of load acting on them. So basically, stone is a very hard, tough, and durable material. In the earlier classes, I have told you about. Now today, I am going to tell you about the properties of a stone. What are the engineering properties of the stones due to which we use them in our construction work? First of all, I will tell you about the crushing strength. The crushing strength of a good building stone should be greater than 1000 kg per centimeter square. That means if I am going to apply a load on a stone like this, the stone should not be break. Having the crushing strength more than 1000 kg per centimeter square. That means it is hard enough to resist the load acting on it. Second one, the appearance. Good building stone should be a uniform color, free from clay holes, spots of other color bands, and capable of preserving color for a long time. That means a stone, a good building stone having the quality of uniform color throughout its body. Okay. Now durability. A good building stone should be durable. That means it having the factors like cold, alternative weight, and dry, dissolved gases, rain, wind, heavy, doesn't affect the durability. That means if as we know that we are using stones from our ancient times, and the structures are withstand from the day of construction to till date without any failure. So that shows that the durability of stones doesn't affect by the weathering conditions, rain, water, and frost. Let me tell you about the fracture. A good building stone having its fracture should be sharp, even, and clear. That means a stone is broken into the pieces, it having the sharp edges, pointed corners, and rough texture. That means the fracture should be clear and plain. It doesn't having a round corners or a round edges. It having a clear and sharp points, edges, and corners. The percentage of wear of a good building stone should be equal to or less than 3%. So the wear is now I will tell you about the wear. The wear is a phenomena in which the stones are rubbing each other, and due to the rubbing action, the stones are not going to convert in the powdery form. If a stone converted into a powdery form, so the stone is not fit for using in construction work. So it having the wear percentage less than 3%. Now the hardness, as we know that the stones are very hard and having a greater value of hardness, so it can resist any kind of forces acting on it. So let me tell you about the hardness index, so that we can decide whether the stone is suitable for our construction work or not. The first one, if the hardness of the stone is greater than 17, it is used for road work. As the many loads are moving on the roads, various types of vehicles are moving on the road, due to the continuously rubbing actions of tires and friction, the stone should be resist and withstand on by the load acting on it. So if it is having the hardness greater than 17, it is used in road work. Now, if the hardness lies between 14 to 17, then it is considered as a medium stone. And if the hardness is less than 14, it is considered as a poor stone, and it is not fit for using in our construction work. Now let me tell you about the resistance to fire. A good quality or a good building stone should be fireproof, as we know that the igneous rocks are formed by the volcanic eruptions and the cooling of hot magma lava and converted into the rock solid. So it is clearly states that a good building stone should be a fire resistant. Sandstone and argillaceous rocks are the best example of the fire resisting stone. A good building stone should have greater than 8.7 specific gravity. The building stone should having a specific gravity less than 8.7 is not considered as a good building stone having a poor. Now let me tell you about the water absorption. a good building stone should have a water absorption less than 5% by its weight. The properties which I have told you, we will discuss, and I will give the tell you about the test, how we can find out the various properties. Now let me tell you about the toughness index. The toughness index of a good building stone should be greater than 19 and should not be less than 13, so that the stone is considered as a tough or enough to take the loads and use for the construction work. Now let me tell you about the test on the stone, the properties which we have studied earlier. So we need to identify whether the stone is capable, or the strength or the water absorption which we are claiming is verified or not. So it can be verified by testing the stones. The first one test is a crushing stone strength test. Second one is a water absorption, to finding out the water absorption. Third one is the abrasion test, to find the wear and tear of a stone. Now fourth one is the impact test, to find out the stone is capable of resisting the load acting on it. And the last one is the acid test. So for carrying out the crushing strength test, the stone specimen should be a size of 40 cross 40 cross 40 mm, and it is prepared. Then the edges and sides of the stones are finely dressed. That means it doesn't need to be uneven. It needs to be smooth and uniform surface. And it is kept for 3 days, so that the surrounding moisture present in the stones can be vanished off and the stone becomes dry. The saturated specimen is provided with a layer of plaster of Paris on its top and bottom of the surface to get even surface. Somehow it is not possible for us to make the stones uniformly throughout the edges and throughout the surface. So to avoid this and to get a better result, a layer of plaster of Paris is applied on it to get a uniform surface. Then a uniform load is applied on the stone, providing a 5 mm thickness of wooden plank if plaster of Paris is not available. Then the load is applied on the stone by the compression testing machine at the rate of 40 Newton per mm square per minute. That means the load is applied 40 Newton per mm square during the 1 minute. Per minute, each minute 14 Newton per mm square load is applied on it. Now noting the crushing load is noted, and the point at which the cracks occur is noted as a crushing strength of the stone. So the stone is tested in a UTM, that is uniformly testing machine. As we can see that the load is first applied on it and the stone suddenly just break. That means the point at which the cracks start defines the crushing value of the stone. Let me again see that the load is applied by the machine and the point at which the cracks fail and the stone breaks into the two pieces. The point at which the cracks start defines the crushing value of the stone.